Okay, so today we're starting chapter 8, and we are going to be dealing with right triangles in this chapter, okay? And we're going to be creating a toolbox for ourselves, and we're going to learn how to use different tools to solve for different parts of right triangles. And it's important to know when to use which tool. Just like if you're going to, put a screw in the wall, you're not going to use a hammer, correct? It won't work too good. It'll strip it, yes? You have to use a screwdriver, okay? Or a drill, or whatever it is that you happen to want to use. And so you got to learn when to use which tool when dealing with right triangles. And we're kind of going out of order. We're covering 8.2 first, and then we'll go back to 8.1 tomorrow, because there's some situations in 8.1 that's helpful if you know information about 8.2. And we've already talked a little bit about the Pythagorean theorem. You guys have covered it previously. We've talked about it a little bit in here. But we're going to get a little bit more in depth with it. The Pythagorean theorem, you use it when you know two sides of a right triangle and you're looking for the third side. Okay, that's when we use the Pythagorean theorem. And it's a squared plus b squared equals c squared. Your a and your b are always your legs of your triangle. And your C is your hypotenuse. And it's always the longest side, and it's across from the right angle, okay? So your Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared, okay, always. Okay, so let's work a couple of examples. In this triangle here, we have a right triangle. We know two sides of it, and we're looking for the third side. So we're going to use the Pythagorean theorem. So we're going to do x squared plus 7 squared equals 14 squared. And so we have x squared plus 49 equals 196. Subtract 49 from both sides, and we get 147. And so then we take the square root of both sides. Now, I want you to give exact answers. Okay, what does it mean to give an exact answer? Well, an exact answer is not rounded. Previously, when we did the Pythagorean theorem problems, I just let you guys plug that into the calculator and get an answer and round the nearest 10, okay? And you can do that if it's a word problem, because a word problem, you want a more tangible answer. You don't want to give an answer like 2 radical 3 feet high. That you don't really know what that is. You want to give actually how many feet that is, or at least close to it. But if it's just a problem like this, then I want an exact answer, which means it's a fraction or it's in radical form. No rounding occurs, okay? All right, so we want to simplify this. And this is kind of a bigger number. It doesn't follow the divisibility rule for 9 or 4. But I do notice that if you add these digits up, you get 12. And any number where you add the digits up and you can divide 3 into it, then the whole number is divisible by 3. And if you divide 3 into 147, it goes 49 times. And 49 is a perfect square. So this breaks into 49 times 3, and so it ends up being 7 radical 3. Now on this next one, if I work it out, I know my two legs, and I'm looking for the hypotenuse. So I'm going to do 3 squared plus 4 squared equals x squared. And 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Take the square root, and x is 5. Now this particular triangle is a special type of triangle because those numbers are what we call a Pythagorean triple. And a Pythagorean triple is when you have 3 whole numbers that satisfy the Pythagorean theorem. Okay? These are whole numbers. They're not fractions, they're not decimals, they're not radicals. Okay? That's called a Pythagorean triple. And so I knew that the answer was 5 without even doing any work. Okay? Here is a list of some of the triples. There's one more that we'll talk about here in a minute. But 3, 4, 5 will always give you a right triangle. Okay? As long as the things are in the right places. This has to be a leg, and a hypotenuse. And then you can do families of that. So like I could take and multiply each one of these sides by 2 and get 6, 8, 10. Or I can multiply each of them by 3 and get 9, 12, 15. I can multiply through by anything. And those numbers will always give me a right triangle. 5, 12, 13 is another one. These first two we see a lot. Okay, you can do families of this one, which if I did multiply through by 2, I would get 10, 24, 26. I could multiply through by 10 and get 50, 120, 130. Those are three whole numbers that satisfy the Pythagorean theorem, which means they're called the Pythagorean triple. 8, 15, 17 is another one. Again, I can multiply through. I'm not going to do all of these. I can multiply through by 2. 7, 24, 25 is another one. Those are whole numbers that satisfy the Pythagorean theorem. Now, this was a triple here, like we said. But is this a triple? No, because this has a radical. Okay? Or if it had a decimal or a fraction, it might satisfy the Pythagorean theorem, but it's not considered a triple because they're not whole numbers. Okay, so if we know these triples and we become familiar with them, it shortens our work just a little bit. Okay? Because I can look at this and I can find x without having to even do any work. Okay? What do you think it would be? 24. What family is this from? The 5, 12, 13. So it's from the family 5, 12, 13, and they went through and multiplied them all by 2. And so x is 24. But you do have to be careful because the links have to be in the right spots. Let's say this was 3 and this was 5. Is x going to be 4? No, because it's the hypotenuse and it has to be the longest side. So if it was arranged like that, I would still have to go back and do the Pythagorean theorem and get my answer. So it would be 9 plus 25 equals x squared. And so in this case, x would be radical 34. And 34 can't be simplified. Okay, so let's apply this. The Pythagorean theorem is a pretty powerful tool. It can be used in a lot of ways, not just in geometry class. Okay, you can use it in a lot of areas. David is locked out of his house. The only open window is on the second floor, which is 12 feet above the ground. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from the house to avoid some bushes, what length of ladder does Damon need? Okay, so we have his house, and he's got a window on the second floor, and he's got these bushes below the window. It says that the window is 12 feet high from the ground, and he has to borrow a ladder from a neighbor, okay? And the closest that he can get the ladder is 5 feet from the house. I need to know how tall the ladder needs to be. What would it be? 13. It is a triple, right? 5, 12, 13, okay? And so that's an example of when you wouldn't have to do it. Now, most of the time in the real world, our numbers aren't perfect like 5, 12, 13, right? But I can think of a real example of when I kind of thought of this and how it might be helpful. And back when I first started teaching, and I think it was my third year to teach, I taught Waco, Texas, and it was the year of the mirror bombing. And I remember, I think I was teaching the Pythagorean theorem at the time, so that's why it might have made a bigger impact on me. But I remember watching on TV and the horror of all that had gone on, and the whole side of the building had, been crashed down, and there was all this rubble down below, and there were people that were still standing on the floors that remained up high, and there was all this rubble, and they couldn't get to them. They couldn't get to them to get them down, and they were all afraid because they thought there was going to be another bomb, and this, that, and the other. And I remember seeing the firemen and just volunteers and stuff. They were scrambling to go get these ladders, and they got this ladder and they leaned it up, and it wasn't tall enough, and they couldn't reach it. And so, if you were a fireman and they trained you just a little bit in the Pythagorean theorem, you might have could put that into play, and it would have involved some estimation. But if you estimated about how tall, how high up they were, and then about how far out the rubble went, then you could have done a little problem in your mind and said, okay, well, I need at least a 50-foot ladder instead of a 25-foot. Does that make sense? And it would have saved you some time. Okay, and you could do that in a lot of areas. But anyway, Pythagorean theorem, a lot of applications. Okay. So now we're going to talk about the converse of the Pythagorean theorem. And what it does is it allows us to look at three lengths and determine if it makes a right triangle. You can also use a version of that to determine if it's acute or obtuse. So we're going to talk about that as well. But if you get three lengths, and first of all, you have to check to make sure that the lengths make a triangle. You remember what we have to look at in order to determine if they actually would make a triangle? What's the rules? Do you remember? If any two sides add together to be greater than the third side, right? Any two sides always have to be greater than the third side. And so if I add these two together, that's going to be greater than 41. So this is going to make a triangle, right? Okay, so that's the first thing you got to check. Then you're going to do, check the Pythagorean theorem. And so you could do 9 squared plus 40 squared equals 41 squared. And so you get 81 plus 1600 equals 1681. And so you get 1681 and 1681. Is that true? Yes. So the answer would be yes. Triangle ABC is right. Is it a triple? Is it a triple? Yes. It is a triple, right? Why? How do we know? Does it make a right triangle? Yes. What is the other thing you have to check? And they're all whole numbers. If they had been fractions or decimals or radicals, then it could have made a right triangle, but not necessarily a triple, okay? It has to be whole numbers that make a right triangle. Okay, so we can also use this to determine if it's acute or obtuse, because if it's not right, then it either has to be acute or obtuse, right? So, and you always want to look at it in terms of the longest side. This is something that's always been hard for me to remember, so I've kind of come up with this. If you look at it in terms of the longer side, it makes a little bit more sense. If the longest side squared is less than the sum of the squares of the other two sides, it's going to be acute because acute is smaller, right? Okay? So it's less than, but you have to look at it in terms of the longest side. So if c squared is less than a squared plus b squared, it's going to be acute. If c squared is greater than a squared plus b squared, it's going to be obtuse. Because obtuse is bigger, right? That's the greater than. So let's look at a couple of examples. We want to first determine if it's a triangle, and then we want to determine if it's right, acute, or obtuse. So looking at this first one, 7, 14, 16, this is, first of all, make a triangle. Yes, okay, so yes, it is a triangle. Okay, then we want to test it, and we want to do it in terms of the longer side. So 16 squared, and then we do 7 squared plus 14 squared. Now, 16 squared is 256, 7 squared is 49, and 14 squared is 196. Okay, so 49 plus 196 is 245. So we have 256 and 245. 256 is greater than 245. So what kind of triangle is this going to be? The obtuse. And that longest side is greater than the sum of the squares of the other two sides. Now let's look at the next one. Okay, is it a triangle, first of all? Yes. Okay, so we end up with, yes, it is a triangle. And so then we would take the longest side, 52 squared, and compare it with 20 squared plus 48 squared. Okay, well, 52 squared is 2704. 20 squared is 400. And 48 squared is 2304. Well, if I add those two together, I get 2704 and 2704. Those are equal. So what does that make this? A right triangle. Is it a triple? Yes, it is a triple. Can you see what family it's from? 5, 12, 13, right? 5 times 4, 12 times 4, 13 times 4. Okay? So it is a triple. All right, last one. We take, first of all, is it a triangle? Yes, it is a triangle. And so we take the longest side, which is 16 squared, and compare it with the sum of the squares of the other two sides. 16 squared is 256, 8 squared is 64, and 15 squared is 225. So if I add those together, 64 plus 225 gives me 289. the other side is 256. Well, that's less than 289, so what kind of triangle is this one? Acute. Okay, so we talked about Pythagorean theorem, and when do we use the Pythagorean theorem? It has to be what kind of triangle? A right triangle, and what do you have to know? At least two sides, and you're looking for the third side, right? Okay, it has to be a right triangle, and you know two sides, you're looking for the third side. Okay? We talked about what a Pythagorean triple was, and those are three numbers that satisfy the Pythagorean theorem, but those three numbers have to be what kind of numbers? Whole numbers. They can't be fractions or decimals or radicals. Okay? You can have those that make a right triangle, but in order to be a triple, it has to be whole numbers. And these are the different families. Then we talked about how to determine whether it was right by using the Pythagorean theorem. Okay, a squared plus b squared has to equal c squared. But what about if it's acute? The longest side squared is less than the sum of the other two sides. And if it's obtuse, the longest side squared is greater than the sum of the squares of the other two sides. All right, any questions? Okay.